Okay, hi guys, so let's continue on seeing some more questions on limiting agent and percentage yield. Okay, so next question is PCl5 reacts with water and forms H3PO4 according to the following reaction. This is the reaction. I have already balanced the reaction. Okay, so now if 0.4 moles of PCl5 combines with 1.84 moles of 1.8 moles of H2O, then what is the limiting agent and what is the mass of HCl produced? Okay, so if 0.4 moles of PCl5 combines with 1.8 moles of water, then what is the limiting agent? First part of the problem is what is the limiting agent. Limiting agent is for PCl5, and for water it is something like this. So obviously this is greater than 0.4, hence PCl5 is the limiting agent. Okay, now next we have to calculate mass of HCl produced. Okay, so mass of HCl produced would be determined by PCl5. So 0.4 moles will give out 2 moles of HCl. Okay, so 2 moles of HCl into 36.5, which is the molar mass of HCl, that gives 73 grams of HCl that would be produced. Okay, next, what would be the percentage yield of the HCl? We have to calculate. If experimentally we know that we have already only got 65.7 grams of HCl, so percentage yield would be 65.7 divided by 73 into 100. That would give us 90% yield. Okay, and percentage yield of the reaction would be obviously for H3PO4 you can calculate the mass that would be present. For H3PO4 percentage yield as far as H3PO4 is concerned was 100%, means whatever at stoichiometry the mass of H3PO4 should be at stoichiometry the same mass we actually get from the actual reaction as well. So for calculating percentage yield of overall reaction, you can just combine the weight of both and you can just divide the stoichiometry weight of both and multiply it with 100. Okay, this percentage yield is for HCl. Let's see another example wherein we have to calculate the mass of KClO3 required to produce 1.49 grams of KCl if percentage yield of the reaction is 100%, and B if percentage yield of the reaction is 40%. So calculate mass of KClO3 required to produce 1.49 grams of KCl if percentage yield of reaction is A 100% and B 40%. Okay, so 2 moles of KClO3 when heated forms 2 moles of KCl plus 3 moles of O2. This is the reaction. Okay, so this implies that 2 moles of KClO3 decomposes to form 2 moles of KCl. So in other words, we can write 1 mole of KClO3 will decompose to form 1 mole of KCl as well. Okay, and 122.5 gram are there in 1 mole of KClO3 will form 74.5 moles of, or rather grams of KCl. Now we have to determine 1.49 grams. Okay, so for getting 1.49 grams of KCl we would need 122.5 over 1.49 or rather divide by 74.5 into 1.49. This would be 74.5 into 1.49. So this is we require 2.45 grams of KClO3 for A part. Now when the yield yield was 100%. Now B part is yield is only 40%. Okay, so for this thing now we would rather do that 122.5 gram would produce 74.5 gram when the yield was 100%. Now, or rather you can say that 1.49 gram of KCl were produced if we had 2.45 grams of KClO3 in the mixture. Okay, but now as the yield is only 40%, then obviously you have to divide it by 2.45 gram by 40%. Okay, because this would give you the extra gram which is needed for KClO3 to be present in the mixture. Okay, so that comes out to be 6.125 grams. Okay, now if you take the 40% of this grams of KClO3, you will get these grams, and from 2.45 gram you can get 1.449 grams of KCl. Okay, so you will need extra grams of KClO3 if the yield is lesser than 100%. Okay, let's do another question wherein we have 2.5 gram of an impure sample of CaCO3 on treatment with 2.5 gram of impure CaCO3 was treated with excess HCl, which produces 0.88 grams of CaCO2, rather CO2, not CaCO2. So CaCO3 on heating with, or rather on reacting with 2 moles of HCl will produce CaCl2 plus H2O plus CO2. This is the reaction which takes place. So 2.5 grams of impure CaCO3 on treatment with HCl produces 0.88 grams of carbon dioxide. What is the percentage purity of the sample? So first part is you have to calculate purity of sample. So if we go by the number of moles of CO2 that were produced, so number of moles of CO2 that were produced would be 0.02. Okay, by dividing 0.88 with 44 we get 0.02, hence 0.02 moles of CaCO3 must have been consumed. Okay, and so the given mass of CaCO3 must have been, or mass of CaCO3 must have been 0.02 into 100. Okay, so it should be ideally 2 grams. Only 2 grams should have been consumed, but we have been given 2.5 grams of CaCO3, hence impurity would be 2.5 minus 2 grams. Okay, so this is 0.5 gram. So in the mixture 0.5 grams impurity is present, hence purity of the mixture would be 2 divided by 2.5 into 100. You can calculate it. Okay, so that should come out to 80%. Okay, so the next problem or the next sub part of the question is, if the mass of CO2 produced is 1.76 grams, then calculate the mass of CaCO3 sample. Okay, so now I have been given that if the mass of CO2 present is 1.76 grams, calculate mass of CaCO3 sample. So now mass of CO2 produced is 1.76 grams, hence number of moles of CO2 present would be, just have to divide it with this, so you will get 0.04 mole. Okay, so now as per the equation, number of moles of CO2 consumed would be, or rather produced would be, equal to the number of moles of CaCO3 consumed. Okay, so mass of CaCO3 that should be consumed, mass of pure CaCO3 rather, would be 0.04 into 100, that would be 4 grams. Okay, and what is the percentage purity? Purity is 80%. Okay, so now total mass of CaCO3 that should be used in the mixture would be 4 upon 0.8, that should come out to be 5 grams. Okay, so total mass of CaCO3 with impurity, or the sample rather, you can say that it should be 5 grams. Okay, so from that 5 gram, percentage purity would be 80%, hence 5 into 0.8 will give us 4 grams, and this 4 grams should be used to produce 1.76 grams of CO2. Okay, so the mass of the sample, that is pure CaCO3 plus impurity, should be 5 grams. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing more examples on the same lines, and then we'll be seeing heating effect on certain carbonates and bicarbonates. So till then, good luck and goodbye.